Good day. You're welcome to this special class, chemistry class. We'll be looking at non-metals and their respective compounds. First of all, we'll be looking at hydrogen and its compound. Hydrogen and its compound. Hydrogen, being the first element in the periodic table. It was first discovered in 17th centuries by a scientist named Cavendish, but was later named by Lavoisier as hydrogen, which means water former. Water former. As you know that when hydrogen combines with oxygen in 2:1, it gives water. So hydrogen is known as water former. That is the meaning of that Greek word, hydrogen, water former. Hydrogen is a gas, and it is a diatomic molecule. As from the configurations, you can see that hydrogen is having just one electron in its outermost shell, and the electronic configurations of hydrogen shows that hydrogen is having just one electron in the outermost shells. The electronic configuration is simply 1s1 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 is having just one electron in its outermost shell, and for that reason, to become stable, it's the outermost shells need one more electrons, and we will be having the shell, which is the s shell, s orbitals, having just one electrons. So there is a need for one more electrons to enter into it, and for that reason another hydrogen comes in and fill in that space, and we're having hydrogen to hydrogen single covalent bond, and that gives us hydrogen molecule. So hydrogen exists as a diatomic molecule. Also, hydrogen, the oxygen state of hydrogen is in 2. The common oxygen state of hydrogen is +1 oxidation state, while in hydrides we have -1 oxidation state. -1 oxidation state. So hydrogen can exist in +1 oxidation state simply by losing an electron. So if hydrogen loses electron, it becomes H+. Then in hydrides we have H-, meaning hydrogen has gained 1 electron. So that makes hydrogen to have a unique property, and that unique property means hydrogen belongs to group 1 element, which always lose electrons to become +1 oxygen state, and also could also belongs to group 7 element, which may gain single 1 electrons to become -1 oxidation state. So hydrogen have that unique property of belonging to 2 different oxidation states. That is one unique property of hydrogen. We also have something about hydrogen. Hydrogen has 3 different isotopes. Hydrogen has 3 different isotopes, and which we must note. Now, the isotopes of hydrogens, we have the first one having one mass of 1, and atomic number of hydrogen is always 1. The name of that is called protium. Protium. That is water former, the normal water former. That is the normal hydrogen that we know. And we also have another isotopes, which is deuterium, with mass number of 2. That is deuterium. It's having the mass number of 2. And we have the third one, which is the one with mass number of 3. That is tritium. The deuterium is heavy water former, while tritium is radioactive in nature. As you can see, the difference between the three of them is their mass number. The mass of the first one is just 1. The mass of the second one is 2, meaning it's having both the neutrons and proton in their nucleus. The first one is lacking neutron, while the second one is having 1 neutron and 1 proton, making mass of 2. Then the tritium, the radioactive substance, is having 2 neutrons and 1 proton. That makes it 3 mass of 3. So these are the 3 isotopes of hydrogen which must be noted. The 3 of them behaves the same way chemically, but their physical property is actually different. So that is the isotopes of hydrogen. Now to the preparations of hydrogens, we'll be looking at both the laboratory preparations of hydrogen and also the industrial preparation of hydrogen. First of all, we look at the laboratory preparations of hydrogen. First of all, when metals react with dilute acid, it liberates hydrogen gas. When metals react with dilute acid, it gives hydrogen gas. Hydrogen gas is liberated. Let's look at hydrochloric acid reacting with zinc. It will give us zinc sulfate and liberate hydrogen gas. This zinc, it has to be zinc chloride, not zinc sulfate. It has to be zinc chloride. So hydrogen reacting with zinc will give us zinc chloride, not zinc sulfate. So it is zinc chloride. Now if it is sulfate, zinc chloride, Cl2. If it is sulfate, we have to balance it, put into here. If we have H2SO4 plus the same zinc, the first one that I wanted to write, that is zinc sulfate plus H2. It is the gas. That is the reactions of zinc with hydrogen tetrasulfate 6. So it liberates hydrogen gas. So also we can have some active metals reacting with water. Active metal like sodium, when we react with water, we liberate hydrogen gas. It will liberate hydrogen gas. It's if it is in the limited supply of water, we'll be having sodium oxide. But if it is enough, when we have enough water, then we should be expecting sodium hydroxide. So when we have water supply in large amount, we'll be having sodium hydroxide produced. We'll be having sodium hydroxide, NaOH, and it will liberate hydrogen gas. We need to balance the equations because we have water produced. This has to be also 2 we're going to have 2 sodium. Since we have, so we are going to have 2 sodium hydroxide. I think it's balanced there, that you're having 2 sodium, 4 hydrogen, 2 here, 2 here, 4. What oxygen is 2, 2. So that is reaction. If it is in the limited supply of oxygen, of water, it's going to be Na2O, which is sodium oxide, plus H2, meaning you are going to have just Na plus H2O in that case. So 2 molecules of sodium will react with just 1 molecule of water there. That is in the limited supply of water. So in this case, we're having hydrogen liberated. That is our purpose. So when reactive metal like sodium or potassium react with water, it liberates hydrogen gas. Another thing we'll be looking at is some metals, when heated red, reacting with steam. Some metals, when react with steam, like iron and aluminium. When aluminium react with metals, react with water, with steam, with steam, it gives us, it liberates hydrogen gas. But in the case of iron must be heated red. When iron is heated red, it will produce hydrogen gas. In that case, iron is heated red. Iron plus steam, H2O gas. It will give us Fe3O4 plus hydrogen gas. In that case, we are having, this is iron 2 di-iron 3 oxide. That is what it's produced. In that case, I think we need to balance this. This has to be 4 water now, since we have 4 oxygen there. So the moment we are having 4 water there, we'll be having 4 hydrogen here too. Then iron is 3. So in that case, we have hydrogen liberated when iron is heated red, and is the steam is allowed to pass through it. Then we have hydrogen gas produced. Things we'll be looking at. Another things we'll be looking at is the industrial preparation of hydrogen. We are going to first of all looking at preparations of hydrogen from water gas. The process, we call it Bosch process. The Bosch process. In this case, the water gas is allowed to react with steam in the presence of a catalyst, iron 3 oxide, at a temperature of about 723 Kelvin. If the reaction take place, the carbon 2 oxide, since the water gas is a mixture of carbon 2 oxides and hydrogen gas. So in that regard, if the carbon 2 oxide and the hydrogen gas present in the water gas react with steam, there will be a production of hydrogen gas. Why this is carbon 2 oxide and H2, which is water gas. This is what we call water gas. So in that, if this reacts with steam in the presence of a catalyst, which is iron 3 oxide, Fe2O3, then this carbon 4 oxide will be, carbon 2 oxide there will be oxidized to carbon 4 oxide, and the steam will be reduced to hydrogen gas. So this is an industrial way of producing hydrogen gas in large amount. So that is the preparation, industrial preparations of hydrogen. This should be 2. Okay, should be 2. So another method is the preparations of hydrogen from methane. When methane reacts with steam in the presence of nickel catalyst, there will be libations of hydrogen gas, methane, CH4, reacting with steam in the presence of nickel as catalyst. There will be productions of carbon 2 oxides and libations of hydrogen gas. We'll be having like about 6 hydrogen there. That is 3 molecules. So this is a very important method used in industry to prepare hydrogen gas. Another method is through electrolysis. During electrolysis of some chemicals like brine, like acidified water, and also other compounds, there is a production of hydrogen gas. So another method of preparing hydrogen gas is by electrolysis. So those are the methods that we use in preparing hydrogen gas. Now we'll be looking at the physical properties of hydrogen. Physical properties of hydrogen. First, hydrogen is a colorless, is an odorless, and a tasteless gas. It's a colorless gas, is a tasteless gas, is odorless gas. Hydrogen is the lightest substance known. It is very light, the lightest gas known. That is the hydrogen. And initially I told you it exists as a diatomic molecule. It exists as a diatomic molecule. Hydrogen is neutral to litmus paper. Those are the things you need to note. Is neutral to litmus paper, and it is insoluble in water, as is very, very insoluble, relatively insoluble, because it's just about 2% of it that will dissolve in about 100 cm3 of water. So it's very, very insoluble in water. And hydrogen does not support combustion. Hydrogen does not support combustion. And finally, hydrogen has a very low boiling point. That's a very low boiling point. Boiling point is about minus 253 degrees Celsius. So those are the physical properties of hydrogen. Now we'll be looking at the chemical properties of hydrogen. First of all, how hydrogen reacts with some element. So we are going to look at direct combinations of hydrogen with other elements. First of all, reactions with metals. When hydrogen reacts with metals, it will give us hydrides. We've said it before. It gives us hydrides. When hydrogen reacts with metals, let's look at reactions with metals like sodium. It will give us sodium hydride. To give us sodium hydride, balance the equation. So if it is calcium, it's going to be hydrogen reacting with calcium to give us calcium hydride. So this is hydrides. These are hydrides. Sodium hydrides, and this is calcium hydrides. Also, hydrogen directly combine with elements like oxygen and halogens as well. When hydrogen combine with oxygen, it will say hydrogen bonds in oxygen or air to give us a pop sound. To produce water. Hydrogen reacting with oxygen to give us water is in the ratio 2:1 to give us 2. So that is another direct combinations. I said it also reacting with halogens like chlorine. This one, it's occur in the presence of ultraviolet light to give us hydrogen chloride. This hydrogen chloride can dissolves in water to give us hydrochloric acid. So these are the direct combinations of hydrogens with other elements. Another chemical property of hydrogen is the reducing ability of hydrogen. That is another property of hydrogen. That is chemical property. Hydrogen is a good reducing agent as it reduces oxides of some elements into their respective elements, like oxides of copper, zinc, iron, and lead. When they react with hydrogen, those oxides are reduced to their respective metals. Let's say, for instance, copper, 2 oxides, when react with hydrogen, will give us copper, and the hydrogen is become oxidized, and we have water produced in that case. When you have iron, let's look at iron 3 oxide. If we react with hydrogen, it will give us iron, and be having water produced. How many water are we going to have? We should be having like 3 molecules of water, since we have 3 oxygens there. So the hydrogen has become 6, so we balance it 3. So iron here is 2, so you put 2 here. So that is that. So the same thing for lead 2 oxides, and also zinc oxides. When they react with hydrogens, it will reduce them to the respective metals. Now, to the uses of hydrogen, we have different uses of hydrogen. First, hydrogen is used in manufacturing some substance like ammonia, hydrochloric acid, and methanol. So we use them in productions of those important compounds, and you should know the uses of ammonia and some acid. They use them in productions of fertilizer and other chemical substances. Then we also have hydrogen being used in adding of oil. It is used in adding of vegetable or animal oils. That is in productions of some substance like margarines and the rest. We also use hydrogen in productions of some gases like water gas and cold gas. Cold gas, water gas, we use them. We use hydrogen in producing them. Then we also use liquid hydrogen as a rocket fuel. We use it as a rocket fuel. Hydrogen, because of its low density, we use it in filling balloons. Use it in filling balloons. So those are the uses of hydrogen. You can check other uses from the notes you have before you. Test for hydrogen. Test for hydrogen. If you are testing for hydrogen, when you insert a lighted splinter into a test tube containing that hydrogen gas, it will burn with a pop sound. That is a unique thing about hydrogen. So it is hydrogen that give you a pop sound. So in case you are asked which of the gas produce a pop sound when you insert a lighted splinter into a test tube, so it is hydrogen gas. So that is the test we use for hydrogen gas. Then also we just talk about the few compounds of hydrogen, especially the hydrides of hydrogen. The hydrides of hydrogen. The hydrides of hydrogen, the simple hydrides like sodium hydrides, I've given you them, the calcium hydride the other times. Now the hydrogen, when these hydrides like calcium hydrides, when they react with water, they produce alkali. They produce alkaline solution. So either calcium hydrides or sodium hydrides, when they react with water, they produce alkali solutions. Like in the case of calcium hydride, you see it, calcium hydride when react with water, CaH2 plus H2O, this can give us calcium hydroxide, and it will give us hydrogen gas. Now that is the reactions of the calcium hydride with water. We also have some important hydrides. The hydrides of boron and aluminium. These have a complex covalent structure. They are very important reducing agent, especially in inorganic chemistry. We have example of such compounds like lithium tetrahydroaluminate 3 or sodium tetrahydroborate 3. These compounds are compounds where the hydrogens are so the major constituent of. So those are the compounds of hydrogen, important compounds of hydrogen to be noted. And you must note that the hydrides of hydrogen, like the hydrides of group 1 and group 2 element, that is the alkali and alkaline earth metals, they have crystalline structure and they are of high melting point. They conduct electricity in molten form, and as I said earlier, when they react with water, you see them producing hydroxide, that is alkaline solution. So that is little things about hydrogens that we'll be discussing. In other non-metals, we'll be discussing some of their behavior. So thanks for watching and listening.